Hello guys, I am Miguel Ordóñez and today I'm going to explain how to design an automation solution. By the way, if you're new in this kind of videos, please subscribe to my channel. This will help to improve the content by feedback of you and also give me the support to keep uploading content for this channel. Okay, going into details of what we want to speak. The basics on how to design an automation solution are some steps, which can be divide a process into tasks, describe the individual areas, define safety requirements, describe the operator display and the controls, and create the configuration diagrams for your PLC. So these are the basic steps that you need to follow. Continuing, I will explain each of these steps with an example. The example that we are going to use is an industrial blending process. Basically, there are going to be two ingredients that are going to be put into a mixer, and then there's a drain valve to take out all this material. So here you can have a view of the sketch in which you have an inlet valve, a feed pump, and a feed valve, plus a flow sensor for each ingredient. The configuration for ingredient A or ingredient B is basically the same. Then the mixer has an agitator motor and a switch for tank level measurement. So this switch will tell you if the tank is full or it is more or less empty. And finally, you will have a drain valve. Okay, once I explain this, I will show how we do the first step. Remember, the first step was to divide the process into tasks. So I'm going to divide the process into tasks and areas. So I have these two areas, which are red and blue, which corresponds to ingredient A and ingredient B, which has the same structure, but okay, there are different areas. And we have the mixing area, and finally the drain area. So we have split our problem into 4 smaller problems. This is a way in which you have to approach each automation problem that you have by dividing your problem into smaller ones. The smaller ones are easier, and sometimes you can work step by step and do not have to do such a big task from the beginning. Now I'm going to explain the equipment used for each functional area. For example, for ingredient A and ingredient B, we have the same structure: a feed pump, an inlet valve, a feed valve, and a flow sensor. The only difference is that, okay, one is for ingredient A and the other one is for ingredient B. Then if we go and analyze the mixing tank, we have an agitator motor and the switch for tank level measurement. And finally, in the drain area, we have the drain valve. Now, here comes a small description of the individual functional areas. So we have the ingredients A and B pumps. For this example, the feed pumps motors for ingredients A and B of the mixing tanks has a flow rate of 400 liters per minute and a rating of 100 kilowatts at 1200 RPM. So at this point you can have an idea of which equipment do you need. Here's a good start to order your motors or whatever equipment you need for the project. So later, okay, we said that the pumps are controlled by a start-stop button from an operator station located near the mixing tank. That's going to be the display, which can be, for example, physical buttons, or it can be an HMI in case you want a fancy solution. And the number of starts is counted for maintenance purposes. Both the counters and the displays can be reset with one button. So there's also the maintenance function, in which after some starts of the motor, you will have to alert the operator that okay, the motors have been used for such a long time that they need maintenance. And finally, the following conditions must be satisfied for the pumps to operate. The mixing tank is not full, the drain valve of the mixing tank is closed, the emergency off is not activated. Okay, these are conditions that must be held to operate, but we can see them also as conditions that if they are not fulfilled, the motor should be off. I mean, even if the operator sends the command to turn it on, it should not do it. Okay, later we have the pumps that are switched off if the following conditions are satisfied. The conditions are the flow sensor signal has no flow on 7 seconds and the flow sensor signals that the flow has ceased. Okay, let me explain this. This has a difference between the conditions explained before, because these conditions sense to turn off the motor as equal as if I press a stop button for the motor. So this will be later more clear when we develop the actual program of the PLC. Now I'm going to explain about the ingredients A and B inlet and feed valves. Okay, the feed valves for ingredient A and B allow or prevent the flow of the ingredients into the mixing tank. The valves have a solenoid with a spring return. So basically, you just have to open the valve, you have to use a physical output to turn on the solenoid. And if in case you want to return or close the valve, you have to just set this physical output to 0 in order that the spring will close it. So this is basically what it says later. When the solenoid is activated, the valve is open. When the solenoid is deactivated, the valve is closed. This is because of the configuration of the valve, because it's a solenoid with a spring return. Then we have the inlet and feed valves are controlled by the user program. So we will have buttons to open or close the solenoid, basically. And for the valves to be activated, the following conditions must be satisfied. The feed pump motors has been running for at least 1 second. So again, these are conditions that we can see them as prohibitions on how the motor cannot be turned on. And the pumps are switched off with the following conditions satisfied, that the flow sensor signals no flow. Again, this is a condition that it's equivalent to a reset button, I mean the button with which we turn off the action of our valve. Okay, now I'm going to explain the agitator motor. The agitator motor mixes ingredient A with ingredient B with a rating of 100 kilowatt at 1200 RPM. Again, this is the perfect occasion to start ordering your equipment. Now that you have an idea of the requirements that you have to fulfill with your hardware, you can start asking for your I don't know, the company in which you buy motors, if they got something similar or they have to order it. Anyway, the agitator is controlled with a start stop from an operator station, which counts also the number of starts, and the counters are displayed with a reset button. So the way in which the motors are working in this project are basically the same. So they have a start stop from the operator, and they are counting the number of starts for maintaining purposes, and these are displayed and can be reset with one button. Okay, so the following conditions must be satisfied from the pump to operate. The tank level sensor is not signaling tank below minimum. That's, remember, we have in the tank 2 sensors, one for I don't know, high level and the other one for low level in this case. The drain valve of the mixing tank is closed, so another condition, and the emergency off is not activated. So these are the conditions to operate. Again, we can see them as prohibitions to not let the pump operate. And finally, the pumps are switched off when the following conditions are satisfied, like the tachometer, which is a sensor for the speed, does not indicate that the rated speed has been reached in 10 seconds of starting the motor. This can be because, I don't know, it's blocked, the rotor, or basically there's some problem into the pump, and that's it, how you should turn off the motor. Again, this is a condition similar to a reset or a turn off button. The drain valve allows the mixture to drain to go to the next stage in the process. For us, it's pointless which is the next step, just as an example. So if the solenoid is activated, the output valve is opened, and if the solenoid is activated, the output valve is closed. So it's again a solenoid with a spring return. The outlet valve is controlled from an open-close from an operator stage, so it's again start and reset button for a motor, or in this case a solenoid. And the drain valve can be opened under the following conditions. The agitator motor is off, the tank level sensor is not signaling, tank empty, and the emergency off is not activated. Finally, the pumps are switched off again as a reset when the tank level sensor indicates tank empty. Okay, this usual description of the functional areas are given by your client for who you are developing the project, because they know in detail how they want the solution or your automation solution to work, but you are the guy who is gonna make that possible. Okay, so basically they give you the details and you try to follow them as close as possible. Finally, the switches for the tank level measurements are used to interlock the feed pumps and the agitator motor. Okay, nothing so difficult. Then, once you have already described your functional areas, you have already divided and split your program, your process into areas, you have to show the I/O diagrams. The input-output diagrams represents basically a block with inputs and outputs depending on the equipment that you are using. For example, in this case, the motor. The motor, according to the description explained in the previous slides, has a start and a stop button, which are these ones. The start stop signal. You will have a response signal, which is basically in case that any of the conditions are not fulfilled to operate, you go and turn off the motor. The reset maintenance, which can be, it's gonna be used after the number of starts after the number of starts has reached the number that you need for maintenance. The timer helps for this functions in which you say, okay, if the motor in this time does not fulfill the conditions, then you go and set an alarm because the motor, I will show you exactly which is this one. It's this one. Okay, sorry. The pumps have not reached the rated speed in 10 seconds. For that timer. So later you have the response time, which in this case are the 10 seconds, and the signal motor, which corresponds to if you're a motor for mixing or the pumps, and the outputs are a fault and a start display and a stop display, because this is a feedback that you need for the operator, and the maintenance is also a feedback for the operator. Now for the valve is easier. You have the open, close, and the valve inputs and the displays to show if the valve is open or closed. Nothing difficult. Now, when we talk about Establishing safety requirements. The safety requirements are focused on what happens. I mean, it's really hard, but what happens if the PLC stops working for any reason? You will have to being able to turn off the motors to avoid accidents or basically malfunction of the equipment bypassing the PLC. So as I told you, these are emergencies off switch that are independent of the PLC. They should be located in the operator station, like close to the where the operator is, because it's pointless to put an emergency button far from him. I mean, when you have an accident, you want the fastest reaction possible to it. And you will have input to the controller that indicates the state of the switch. I mean, in spite of being independent from the PLC, you still need to have a feedback to the PLC so that the operator can see that this action has been performed. And now we will have a description of the operator display and controls. As I told you before, this can be physical or an HMI. In case it's physical, you will have this as buttons. This will be pilot lights. In case it is an HMI, we'll have way more possibilities to represent this. And the emergency stop. The emergency stop, pay attention to this. The emergency stop needs to be physical. Remember what we said before. It has to be independent of the PLC. If we do the emergency stop on the HMI, that's not being independent of the PLC, because you need to send that data by the communication protocol to the PLC. And finally, we create a configuration diagram in which we explain how it's going to be working our solution. In this case, we have a PLC. The model can be this one, can be another one. Doesn't matter, as long as it fulfills the requirements of how many digital inputs, digital outputs, analog input, analog outputs you need, the physical plant, and the operator station, which, as I told you before, can be an HMI or can be a physical operator station. I hope that this video was entertaining for you, but most of all, I hope it has been useful. In the following video, I will explain on how the program is structured to go more in detail into the PLC programming. If you have any doubt or suggestion, please feel free to write them into the comment sections, and I will read them and try to improve the content of this channel for you. If you want my help for any program or any project that you have, here are my mail or WhatsApp. Feel free to write me. It has been a pleasure to speak with you today. Bye bye guys, until next time.